Today we're going to work on our useless box programming. So if you remember last time we were in circuits. There's our useless box. So we're going to tinker this. We're going to tinker on this. When we left off last time, we were talking about this resistor, or we just put in the resistor. I want to change that value to 10 kilo ohms. Oops. There we go. That's what we want it to be. And then let's get started on the code. So we're going to code in text. And this is what it starts out to look like. We're probably going to get rid of most of this. I'm going to slide this over and slide this over so I have a little bit more room. All right, so the first thing we're going to do before the void setup, so let's add a few lines at the top, is going to add the library of the servo. So add that in there, and that go ahead and throws that in there. So again, I went to libraries, clicked on servo. Include servo. Okay. The next thing we're going to do is add some variables that we're going to be using. So this code is not that long, but it's still good to start this practice of including variables. So we're going to have a constant variable, going to be a number, and we're going to, this is going to be our switch pin. So where is our switch? Right here into, and it's into 2. So we're going to make that switch pin, it's going to be equal to. And then, like everything, I'm going to put a semicolon, or most lines, put a semicolon at the end. Our next variable is going to be our switch state. So again, this is not going to be constant. It's going to change. The state of the switch is going to change depending on whether the switch is on or not. I'm going to change this to a capital P just because that's typically what people do. Just like this is a capital S. Whatever you do, it's got to be consistent throughout the program. And for right now, we're just going to make that a 0 semicolon. All right. And then, of course, we've got to include our servo. So we're going to call that servo my servo. So our servo is basically called my servo. Okay. And again, comments are always good. So this is create servo object to control a servo. And the last variable we're going to do is the position of our servo. So we're going to call this as an integer, and we're going to call it position or pos. And again, this, just to make this clear, this is a variable to store the servo position. And we could put this up here. This is a variable to store the state of the switch. Okay. We could do the same thing here. What is this? Well, it's a constant variable. For the pin that the switch is connected to. Okay. And now we're into our void setup. And so with our void setup, we're not going to do this pin mode. We're going to change this. Instead of 13, we want it to really be 2. But to be consistent, we're going to put switch pin as the variable. And instead of going to be output, it's going to be input, which has to be all caps. And the last thing we need to tell the board how to set up is to tell it that, hey, my servo which I have a capital S here, so I gotta have a capital S in both places, is attached to the 9 pin. And so yeah. So again, we could put comments in here just to make it easier for us to understand why we put these lines. This sets the pin mode of pin 2 as input. So it will receive electricity from the switch. And this attaches the servo on pin 9. And so you can see that here, that this is the signal that comes into the servo. Tells it where to go. And that's the end of the void setup loop. So the void loop. Sorry, I shouldn't call this a setup loop. The void setup section. The void loop section is a little bit more complicated. So we're going to get rid of all this stuff. Add some lines here. Okay, so the first thing we want to do is read our switch pin. See if anybody has touched this switch to turn it on, because that's what's going to trigger everything to start happening. So let's first read that. So we're going to say switch pin. I'm going to tab this in just a little bit. Switch pin. Remember, it's got to match what's up here. I'm sorry, switch state. State is equal to, and we're going to read the digital input of it. Digital read switch pin. This is where I want switch pin. And again, these have to match this variable, this variable, this variable, this variable. All have to match. So just checking those. That's good. And so that's going to read that. Figure out whether our switch is on. So let's add that comment. Determine if the switch is on or off. Okay. So then what's going to happen is we're going to go into this if statement. So if the switch state, which we just checked, is high, 2 equal signs for that one, capital, then what are we going to do? We're going to do what's in this curly bracket. So I like to go ahead and add in my closed curly bracket now so I don't forget it, and then add a line so I can continue on. All right. So this is going to be what we call a for loop. We haven't talked about for loops, but let's see. Let's go ahead and use it. So for the position of my servo, capital S, read. So we're going to read it, see what the position is, and if that position is greater than or equal to, and for right now we're just going to put in some numbers. We might need to change these based once we get our useless box built. If it's greater than 60, then we want to subtract. This is how you do subtraction. 10 from it. Let me close that for loop. So again, we've got open bracket or open parentheses here, close parentheses there, and so it's going to loop through this next set of curly brackets. And again, I like to put my closed ones in there. Come back up here and continue typing in. And so basically, a comment section could go here. Basically, this is saying it's going to go, well, you'll see later, I'm going to say 100 degrees because that's where it should be if the switch is not high, to 60 degrees. So when it gets basically equal to or below 60, it's going to stop this loop, this for loop. So it's going to go from wherever it is, if it is greater than 60, it should be 100, back down to 60. So that's what that for loop does. And now we need to tell it to do that. So let's just go ahead and say, leave some white space for the users to be able to read. So now we want to tell it to say, hey, move my servo's position. I'm going to go ahead and write to that position, whatever that may be. So if it was 100 and we minus 10, it's now going to be 90. And that's what it's going to read that as. Say, hey, right now it's at 100. Then it sees this, oh, yep, that's greater than 60. Subtract 10 from it. So now position is 90, and we want to move to that 90. And so that's what that line does. And so let's go ahead and say to the reader or to the coder, the human, tell servo to go to the variable position. Okay. And then we're going to delay a little bit, delay the code, really not very much, 15 milliseconds. So I mean, that is not a lot, but just enough time to let the servo move to that position. And then it's going to go back through and it's going to say, okay, I'm going to read my servo's position, am I greater than 60? And of course it would be 90 if it started out at 100. And so it would go down to, yep, I'm greater than 60, go down to 80, move to 80. Go ahead and move, then go back and look. Yep, I'm still at 80, I'm above 60, minus 10, now I'm at 70. And then go back through and eventually get to 60 and say, yep, I'm equal to 60, I'm not doing this anymore, and it's going to jump down here. Okay. So this is where we're going to have our else. So let's just make sure I'm on the right side of these brackets here. This one's for my loop. This one's for my if. And this is for my for, and this is for my if. So after my if one is where I'm going to put my else. So just tab over because it should be about the same as the if. It's really what I want it to be, but it's not giving me that option. There we go. So else. So basically, if the switch state is equal to high, it does this. But if its switch state is low, it's going to do this else. So that basically means the switch is still off or it's been turned off. So we're going to do another for loop. So we're going to close that curly bracket. I like to do that so don't forget it. And then say for, very similar to what we did before, position equals. So basically see where the servo is. Read. And then if that position is less than 100 or equal to 100, then add 10 to it. And close that and open this for loop. Again, I have to close that for loop. There we go. All right. So let's just put a comment in here. So basically similar to this comment, but it's going to be goes from 60 degrees to 100 degrees. And it really might go to 110, because if it's equal to 100, it's going to go ahead and add another 100 or another 10 to it. So might be a little off. These might need to be 110 and 50. And so these numbers could technically change when we get it attached to our cardboard box and see if it actually is going far enough to turn the switch off. And so then again, we've got to tell it, just like we did here. We can really just copy this, Control-C, paste, and basically get all the same thing. So go ahead and move the servo to that position, delay, so it has time to do that, and then let's look at the position. Where is it? Is it still less than or equal to 100? If it is, go ahead and add 10 to it so that it gets above 100. And that is our code. Let's see if we have any bugs. Or we can, never done this before, but yeah, that's our code. And so that's how it should work. Let's go ahead and start simulation and see what happens. So you can see it moved. If we hit the switch, it moves back to this way. Get this out of the way. I'll come in here and move that out of the way. See, so it moves back and forth to that position. Not very far, because I didn't want it to break anything when you guys start building this. And so we're going to have to increase these numbers. So if I wanted to make this go a little bit farther, maybe I bring this down to 30, right? So if I stop simulation, change this to 30, now it's going to move a little bit farther than it did before. You see the difference that it moves. So I can play with that when I get it on the useless box. I can change this to 160, really make it move. How far it went that time, back and forth. Okay, and that is the code that you need for your useless box.